Mumbai, the city where the speed of life often overtakes time. The city which has grown many-fold in multiple aspects. An ancient port city which emerged on the world map owing to its business and trade. As skyline of the city expanded, thousands kept adding to its population. Over the years, one aspect which has grown at a massive pace has been its traffic.
Well, we pay road tax, but we just don't get to use roads as happily as we would like to. And I think that's the story of everyone who stays and drives and travels in our great city.
With city roads choked with traffic, putting brakes on the fast lane, an architectural marvel was carved on the waters to reclaim Mumbai's space.
Earlier, what was Mumbai's leitmotif? One was Gateway of India, second was the Marine Drive. Now, the moment Mumbai picture comes, it is the Sea Link, which actually comes as the motif of Mumbai.
A masterpiece displaying India's excellence in civil engineering, a human story built with concrete and steels.
Look high, you look up, and it's 100 meters plus, structure, and you drive through that, and that's my personal favorite.
A bridge over her seas, the Bandra-Worli Sea Link. For years before this bridge came into being, this red-coloured line on a map depicting heavy traffic was a regular feature on Mahim Causeway, the only road connecting western suburbs to central and southern Mumbai. Life was not so on a fast lane in the Millennium City. The traffic was also a never-ending challenge before the civic agencies.
The city grew northwards continuously, number one. And when it started, original Mumbai city is from Kulaba, Kafparet to Sion. And beyond Sion, last 50 years, it has been exponential expansion, like from Bandra to Dahisar on the western line and on the central line up to Mulund. So this expansion was actually catered to by two expressways, what is called Western Expressway and second was the Eastern Expressway. This Western Expressway caters to the 70% traffic, 70% of the suburban traffic stays on the western suburbs. Bandra, then you have Parle, Andheri, Jogeshwari, Goregaon, Malad, Borivali, Dahisar, so it's huge. Now, this expressway, Western Expressway, when it was constructed in 65-69, by the year 2000, within 30 years of its commissioning, it almost became a local road. It was a 60-meter wide road, which was conceived in 65. Both the expressway, whether it is Eastern, because Eastern started from Sion and it went to Thane. So, both these expressways were conceived in or started, land acquisition was started in 65 and by 69 they were commissioned. And that actually spurred the entire suburban expansion in Mumbai.
I think it's only getting crazier. Unfortunately, the way the BMC functions is something that is perhaps designed to make life as miserable as possible for people who drive cars. First of all, the roads are not in a great condition. On top of that, more than 70-80% of the roads, you just step out of any part of the city and roads are perpetually dug up. So, well, we pay road tax, but we just don't get to use roads as happily as we would like to. And I think that's the story of everyone who stays and drives and travels in our great city. Whether you're traveling by bus, you're traveling by train. Train has its own share of problems, but when you're on the road, whether you're traveling by bus or car, taxi, rickshaw, whatever, I mean, yeah, it's only getting more complicated.
According to a research conducted in 2018, an average journey takes 65% longer in Mumbai. The problem of traffic density also gets complicated, for the public transport in metro cities is often overburdened or simply not preferred by public owning cars and other fleet of vehicles.
I think is that the public transport system in our city hasn't really been promoted well and hasn't really been an enabler for more people to try and use public transport. I mean, all over the world, people are very happy using public transport. When I'm talking about that, I'm even talking of countries like China. I mean, Europe, US obviously is not very great on public transport, but when you're talking about Europe or you're talking about a whole lot of other countries, I mean, the public transport system is only getting better. Even when you talk about China, you talk about a whole lot of Asian countries, Far East countries, South Asian countries, the transport system has only gotten better and tries and reduces congestion. Like, for example, when you have a good bus, like a BST bus that travels, it takes off so much of load off the roads.
By 2000, we started looking at Mumbai. It had already crossed 1 crore population. Out of that, 70 lakh population staying in suburbs, and it is only Mumbai city. We are not adding Thane as a suburb on the eastern side, Kalyan as a suburb, Navi Mumbai as a suburb, Bhiwandi as a suburb, Ulhasnagar as a suburb, and the northern side, Mira Bhayandar and Vasai Virar is another exponentially growing area. Huge, because MMR almost has 2.5 crore population. So it was difficult to cater to the traffic which was originating in the north and coming to the Mumbai city, because the central business district, one is Bandra and second is the Nariman Point. The seat of the government is Nariman Point. So it was thought in 2000 that we should have a freeway, a sea link, which will start from Warsaw on the northern end and go up to Nariman Point.
As the urban overgrowth and traffic volume continue to challenge the pace of Mumbaikars, the authority got to the drawing board and began to work on infusing the breathers in the city commute. One of the ideas was the concept of freeways and the expressways.
What is expressway? Expressway is basically an access control road where traffic can move at a faster pace without any obstruction.
Among the authorities shouldered with the task was the Maharashtra State Road Development Corporation, or the MSRDC, whose collective brainstorming led to the foundation of a sea link. Simply a bridge over the city's sea, connecting two urban hubs and in the process providing an alternate route to several thousands of commuters. Today, the Bandra-Worli Sea Link connects Mahim interchange from Bandra's end to Worli Sea face. The bridge has made a massive difference. What earlier took nearly 45 minutes from Bandra on the western suburb to Worli, a busy district on the south, through an old road of Mahim Causeway, now takes just 8 to 10 minutes. Besides taking care of north-south traffic movement, the Bandra-Worli Sea Link has added another laurel in Mumbai's urban landscape.
It has cut down on traffic time for sure. It's made life easier. Distances have become shorter, but I only hope that it doesn't really become congested like what we have with the Bombay-Pune Expressway. At one point it was supposed to be like a free zone where people could just zip from one end to the other like this, and now we all know how congested it has become, and sometimes it takes like double the time to reach from Bombay to Pune. So I hope that that's not what eventually, Bandra-Worli Sea Link ends up becoming.
Well, the principle of, generally speaking, building sea links, bridges, coastal roads, tunnels, is to create peripheral architecture or peripheral infrastructure around a city so as to actually decongest inner city roads, reduce pollution, noise pollution, alleviate the substantial traffic requirements. And Mumbai, as you know, is an island city, but the land space is actually very limited. And so what the Bandra-Worli Sea Link has done in part is to be part of the Garland Ring Road of Mumbai. In fact, the connectivity from South Bombay via the Mahim route to the northern and western suburbs, which used to basically take about an hour and a half at peak traffic, catering to about a lakh and a quarter vehicles per day, has now been reduced to about 20 minutes. So these are the fundamental benefits of improving the quality of life for the average Mumbaiker, to say nothing of the fact that once you create iconic structures like BWSL, they add to the beauty and the skyline of Mumbai.
It was decided that it will be in phases. We should start on the southern portion first, because first was the Mahim Creek. Right across Mahim Creek you go and we do this sea link first. If we look at the phases, Nariman Point to Worli would have been one phase, or Nariman Point to Haji Ali to Worli to Bandra, and Bandra to Warsaw. Out of that, Worli Bandra Sea Link was done. Worli Bandra Sea Link was specifically done because the bottleneck is Mahim Junction when you come from the north side, and the entire bottleneck continues up to Prabhadevi or Worli. And you have a very interesting phenomenon, what takes almost an hour to commute that particular. If you take a sea link, it takes 10 minutes.
The bridge is today more than just an urban apparatus, easing traffic, now an identity mark of the city. The Bandra-Worli Sea Link is a marvel of engineering technology. Constructed over Mahim Bay, this bridge is the part of first phase of Mumbai's freeway system, designed to ease traffic. With the project yielding favorable results and desired objectives in easing city life, expect some more such sea links in the maximum city in the days to come.
From Worli up to Worli side, on the southern side we have the sea link. From Worli to Nariman Point, or Marine Drive for that matter, a coastal road is coming up. So free connectivity, again access controlled, getting up to the South Mumbai. Now we have been assigned work of connecting the north. The first part of the north connectivity is from Bandra to Warsaw. The existing sea link, the sea link portion is 4 kilometers and the connectors are 1.6 kilometers, that is 5.6 kilometers. The new sea link that we have already started working on, in fact we have given the work order also. Preparatory work is over, all the environment clearance, forest clearance, everything is in place, CRZ clearance, so work mobilization is complete. That is from Bandra to Warsaw. That is 9.5 kilometers of sea link and 8.2 kilometers of connectors. So this sea link should be in place in another 5 years.
Absolutely fabulous. We need more of such. We're very happy just constructing one 8-kilometer sea link, but that's like an old story. You have countries where they've constructed 30, 40, 50 kilometer sea links, virtually connecting two nations. If I'm not mistaken, in Europe, I think Sweden and Denmark, or I think two countries are connected by a huge sea link. China has like multiple sea links. So I don't see a reason why we cannot do that without obviously harming the coastal zone and polluting the sea and damaging water resources. I'm sure if we were to apply, and there's no dearth of resources, there's no dearth of money, or I don't think there's any reason why we can't do it.
But what makes this gigantic wonder really special? A first of its own kind bridge in India to be built on the open seas.
The primary purpose of infrastructure is to improve the quality of life of the citizens of the city. I think that at the same time, infrastructure needs to actually mesh with the beauty of a city to enhance its value, right? And it's incidental that the value of real estate in a city gets enhanced by the number of landmarks one has.
The project to build India's first ever bridge over the seas, which is also the first ever to use cable-stayed technique of balance and ornamentation, was undertaken by state-owned Maharashtra State Road Development Corporation. Established in the year 2000, the state government's pioneer civic agency is responsible for developing, building and maintaining road across Mumbai and state of Maharashtra.
See, MSRDC was a pioneer in it in India, because we started thinking about it almost 20 years before, 1998, and the first clearances we got was in 2000. The CRZ clearance for Sea Link was got in 2003. The pace could have been much faster, but yes, we did. First Sea Link was inaugurated in 2010. Worldwide, such sea links are there. Whether you, in fact, when I had an opportunity to see the Incheon bridge, a 9-kilometer bridge, where you go to sail, especially for a city like Mumbai, which is agglomeration of 7 islands, which is covered on 3 sides by water, basically sea and creek water. So it's there's no alternative. The hinterland is extremely important for us, because that's the only place where we are growing.
But the construction of this massive edifice was entrusted upon the Hindustan Construction Company Limited, or the HCC, one of India's oldest and most reputed engineering and construction giant.
HCC has constructed major landmark infrastructure projects across the country, contributed to nearly a third of India's hydroelectric capacity, over 60% of India's nuclear reactors, 3,800 kilometers of roads and expressways, 375 bridges. I think that we've probably bridged nearly every river in India, and about 330 kilometers of very complex tunneling work, mostly in the Himalayan range. I think what differentiates HCC and makes our company quite distinct is our sheer desire to take on the most complex and challenging of engineering construction jobs.
Going back 94 years, the Hindustan Construction Company Limited has constructed large-scale civil engineering and infrastructure projects like the expressways, highways, tunnels, bridges, and even the hydro and nuclear power plants across the country. Besides Mumbai's Sea Link, the HCC also built India's longest rail-cum-road project, the Bogibeel Bridge over River Brahmaputra in Assam.
Since the completion of the Bandra-Worli Sea Link, 3 landmark projects come to mind. The longest tunnel, India's longest railway tunnel at Pir Panjal a few years ago. And then in the last year, 2 projects inaugurated by our Prime Minister, the Bogibeel Bridge, which is the longest rail-cum-road bridge in Assam, again across the river Brahmaputra, and the Kishanganga hydroelectric project, one of the largest and most complex EPC projects undertaken, and that was done across the line of control.
But the construction was not limited to just these 2 groups. Best and chosen experts from around the world were consulted, as well as tasked in construction at several stages. While the UK-based Dar consultants worked on designs for the MSRDC, experts from nearly dozen-odd countries were roped in to contribute in the making of the Sea Link.
I mean, there was we had a number of partners, experts, service providers on the project. We had technical experts, from Singapore. We had service providers on the design side from various countries in the world. We had suppliers of our bearings, of our cables, of our materials and cement, both in India and abroad. So it was a very diverse set of people and companies that we had to work with to achieve this project.
This bridge, the way you look at today, this sea link, it was not the way it is there. It is not the way it was designed initially. In fact, it went through a number of iterations. I suppose this is the third or fourth final, in fact, third final design and then some improvements. Even the cable stayed portion, the kind of steel that will be used, the steel from where it will be imported, the technology to be used, all those things that started from 2002 and stabilized somewhere in 2006. There were other challenges. Actually, technology was one. What kind of technology should be used? What kind of expertise should be used? We had dark consultants as our consultants at that point of time. So naturally, we didn't have any consultants who had origin in India who could have constructed this kind of bridge. So consultants, we had collaboration of consultants.
The project, given its scale and dimensions, was beset with several challenges. Even before the construction began, the agencies and the partners involved conducted elaborate surveys of the seabed. As this bridge is built on a sensitive ecological zone of Mahim Bay, special care was to be taken to preserve and safeguard the environment. The marine geology underneath the bridge consists of basalts, volcanic tuffs, breccias, and other sedimentary rock deposits. The experts and environmentologists got down to work on the seabed to make it conducive for building a mammoth bridge, whose conception itself was a challenge even before the construction began.
A lot of NGOs and well-meaning people and having some apprehensions to address that, because in all infrastructure project it is extremely important to address the social concerns. So that was also a big challenge. Actually, our delay was not on account of technology. When we started constructing in 2007, because 2007 we actually started the work and completed in 42 months. So technology was not a challenge. Choice of technology, yes, it took some time. It took almost a year for evaluating various options and source of material. If you look at the steel used and the kind of technology which was placed, put into place, it was quite different. It was never used in India at that point.
It was the first of its kind project that was done in the open sea. So I think that we certainly learned many things as we moved along, and we had our fair share of challenges, certainly. Just to give you an analogy, I mean, we take for granted working on land. It's a stable platform where we sit, we talk, we converse, we eat, we read, we watch our children play with their toys and do their geometry homework. I think that you can imagine the tremendous task of actually having constructed this project out in the open sea. So from the foundation works to the superstructure works, all of it having been completed on effectively an unstable platform, so to speak, was the real challenge. The incidental aspects like delays in environmental clearances, which the state government dealt with fairly admirably and finally got that through, were incidental. The real challenge, I think, was the fact that we were working out in the open sea.
Being a first of its own kind in the open seas, the bridge has three essential segments: the pillars, the deck, and the cable stayed portions, whose pylons were designed with complex geometry. Another feature of this 8-lane twin carriageway bridge is that it's designed and built to withstand winds ranging even 125 km per hour over the Arabian Sea. It's also the first infrastructure project in Mumbai to use seismic arresters, which firmed its grip on the seabed and enabled it to withstand earthquake measuring up to 7.0 on the Richter scale.
And when I say open sea, we're talking about Mumbai monsoon climatic conditions. I mean, when it's not certainly by any stretch of the imagination stable. So the surveying work, which needed to be tremendously precise, the transportation of people, machinery, the launching of equipment. Again, all of it needing to be tremendously precise, inspiring our workforce. Even though this project was done in Mumbai, the fact is that it is actually a remote site. I mean, you know, where do you go on your tea break? You're marooned at this site. So I think from a point of view of even the psychological makeup of managing our teams, inspiring our people to stay focused, to maintaining the highest standards of safety, was a major challenge.
See, building bridge of this kind in 2003 was itself a challenge, number one. Number two, how do you do it? Because, you know, you are right on the Arabian Sea. It's open sea. We are on the mouth of the creek. So you have huge tidal effect also on that, number one. Number two, the design of cable stayed, which was never done in India. So it was done in China, then it was, the steel was sourced from Japan. All those challenges were very unique at that point of time.
Running 5.6 kilometers in end-to-end length, the magnitude of this rupees 1600 crore wonder can be estimated from its construction. It weighs nearly 50,000 fully grown African elephants, and the steel wires used in the project can go around the circumference of our Earth. The scale here is amazingly whopping.
We had 3,000 workers on the ground. We had professionals and experts and partners from nearly 12 countries in the world collaborate on this project, and I think that there's a lot of pride in the fact that you had folk from different cultures speaking different languages with one thing in common, which is a love of engineering, bring them together to achieve our masterpiece.
What makes this bridge an engineering masterpiece is how it overcame challenges, starting with maritime ecology. As its foundation was laid on the seabed, highly variable geotechnical conditions of the seabed posed massive challenges. Sometimes the problems were as acute as highly uneven foundation bed, where the piers were to be placed. Further complication included the presence of veritable intertidal zone, with the parts of foundation bed exposed in low tide and submerged in high tide. But step by step, these challenges were overcome.
3 phases. Planning phase. The second phase was the foundation works. And the third was the superstructure, which is, you know, the deck and everything that came above. The foundation works, as I've said, was tremendously challenging because we were out in the open sea. You know, we had to drill 164 piles at very, very precise intervals along to create the legs, you know, for the superstructure that came above. And sometimes as deep as 30 meters into the seabed in very, very volatile conditions. And, you know, in dealing with in the open sea monsoon conditions and tides and so on and so forth. Again, the precision of doing that from an engineering perspective was very, very high. The superstructure that came on the top, again, a 20,000 metric ton carriageway. To be able to construct that in 3 different parts and to make sure that the connectivity when everything got together was very precise was the second part. And as I've said, the diamond shape pylon geometry, where the assembling of the cables and the construction of the support structures for the 124 meter high mast was needed to have been done with such precision, such that when the support structure took the weight of the superstructure, it would actually be perfectly aligned.
One by one, each column was planted meticulously by this giant machine drilling under the seabed. Several of these columns were erected to complete one single pier. Going below as deep as 30 meters under the seabed, these 500 tons concrete pillars placed 50 meters apart from each other carries the weight of a deck formed by prefabricated structures forming the concrete deck of a bridge. Once pillars were laid, these prefabricated concrete blocks were laid by giant launching trusses. Fifteen such segments were laid step by step between the two pillars. These blocks are joined by steel wires and then firmed up by concrete adhesives. Talking about the width and margins of the bridge, each section of the sea link is meant for 4 lanes of traffic, complete with concrete barriers and service sidewalks on one side. Complex geometry too has been infused in the design with meticulous precision. The alignment is defined with vertical and horizontal curves, all compatible with aerodynamics.
Drilling 164 piles, the legs of the bridge on which the superstructure sat, was the other aspect of complex engineering, where again you're working in the open sea with monsoon patterns, with tides, and you're drilling sometimes as deep as 30 meters down into the seabed. And to do that with the kind of consistency, with the highest demands of quality and safety, was probably, I would say, the other huge engineering challenge for us.
But what stands out on this bridge is its cable-stayed portion. The sea link has 2 cable-stayed portions, one on the Bandra Channel and the other on Worli Channel. Both the portions are designed with absolute precision, keeping in mind the dimensions, geology and the aerodynamics. In fact, it's the cable-stayed portion which has also made this bridge a visual treat.
This is the first cable-stayed bridge. Now we will have actually few more hereafter. The second cable-stayed bridge was recently inaugurated in Nagpur. Another cable-stayed bridge is coming in missing. In fact, in Mumbai-Pune Expressway, we are creating a missing. There is a missing link which we are constructing. In that also there is a 650-meter cable-stayed bridge.
You have two major cable stays. The larger cable stay, which is closer to the Bandra end, has approximately a 600-meter span with 2 clear channels of 250 meters each. And the smaller cable stay at the Worli end has a 350-meter span with a clear channel of 150 meters. That essentially, basically, is the the entire the components of the bridge. You have the foundation works, and you have the superstructure and the pylon, which basically rises to about 124 meters in height, which supports the larger cable stay.
Forming a triangular crest over its surface, this cable-stayed portion is first of its own kind in India. It's also for the first time that a cable-stayed bridge has been built on the open seas in India. The cable-stayed of Bandra Channel is 500 meters in length and 126 meters high at its vertex, as high as a 43-story tower, and has 250 meters cables supporting the main spans, flanked by 50 meters conventional approach spans. In fact, it is this cable-stayed channel which supports the superstructure by means of 4 planes of stay cables in a semi-fan arrangement. These aesthetically designed pylons have an extremely complex geometry and forms one of the longest spans for concrete deck. Another benefit of this cable-stayed portion is that it allows for a free movement of fishing vessels, boats and the maritime traffic in Mahim Bay.
We have a very, very beautiful aesthetic structure in its diamond-shaped cable stay, a pylon or the mast, so to speak, which rises about 124 meters in height, is supported by 2 legs which are at slants, and you have a beautiful diamond that, while it's aesthetically very pleasing and what's actually what makes BWSL an iconic landmark, is an extremely difficult task of engineering. Because as soon as you start to actually do construction at a slant, and the easier thing to actually do is take a stable base and just construct vertically up, perpendicular to your base. Soon as you end up, working at a slant, to use an analogy, you're looking to actually construct those legs like a banana, like a parabola, which when it takes the weight of the 20,000 metric tons of superstructure, it straightens out perfectly.
See, this is a 500 meter portion cable stayed bridge. In fact, the cables are actually attached to a pylon. You find that huge pylon, and then you have steel cables. What you find only lines. They are not simple lines. You have huge steel ropes there. Actually, this pylon holds the cantilever on either side. You find there are piers down, but those piers are only supporting. What actually holds the pylon is tall, and pylon actually, in fact, this is the pylon, and on either side you have those steel ropes. These steel ropes actually hold the balanced weight of the entire cantilever.
The channel also had some very peculiar challenges. It was also a crucial test for HCC, the construction partners, handling one of the most prestigious as well as complex civil engineering projects. The deck was laid by these 110 meters long launch trusses weighing 1250 metric tons each. These trusses usually crawl mechanically on the surface after a portion of deck was complete. But for building the cable-stayed portion, the trusses had to be moved from one end of the approach bridge to the other. As the distance between the approach bridge's last pillar and the central pillar of the cable-stayed stretch was 250 meters. 5 times the distance of pillars as on the approach bridge. This was a massive problem, as lifting 1250 metric tons launch truss on mechanical legs was out of question. Dismantling and reassembling the truss for positioning it on the other end would have taken months, pushing the deadline and the costs further up. There, the HCC got on a giant Asian Hercules, one of the biggest floating shear legs crane in the world, weighing 5,900 metric tons. The Asian Hercules, which can lift up to 1,600 metric tons, made task much easier for laying the 250 meters long deck of the cable-stayed portion.
The launching trusses that were in place have all been assembled and calibrated to a high degree of precision. So when it's not as simple as lifting a child's Lego design and moving it from one place to the other. I mean, the machinery requires to be calibrated to a very, very high degree. And I think that the idea itself was brilliant to do that. Very bold, because it hadn't, we hadn't done that before. And any time when we haven't done something before, there is always a bit of a fear. But I think that once, the decision was taken to do that, the real challenge was actually in the logistics of actually moving from one end to the other and navigating, very delicately, over the water and through the minefield, as I described. And we got it done.
Among the challenges before this massive operation was nature of tides and plethora of BSNL cables on the seabed. The operation of lifting the truss was conducted only in night time, as high tide was crucial. By the morning, Asian Hercules moved in the high seas, holding the giant truss like a pin. The trusses were finally placed on the Worli end in the night time, again when high tide supported the operation. The operation, which looked like taking months, was complete in the matter of days.
The goal was to actually pick up the launching trusses at the Bandra end, transport them to the Worli end, and have them reinstalled there. Now it sounds very simple, but the challenge was tremendous, because you had, as I said, open sea, very, very large equipment, tidal patterns. You had very delicate VSNL cabling on the bed. And so we had to use the GPS system and ensure that the operation was carried out in many small steps. So it's like a soldier making its way through a minefield, so as to actually end up, moving this carefully to one end to the other and reassembling. That took a few days, but effectively what we ended up achieving was saving a number of months in the final completion of the project.
It's not just this cable stayed portion which accentuates the aesthetics and architectural laurels of the Sea Link. A relatively low cable stayed twin spans running 350 meters and standing 55 meters above the deck level supports the superstructure at the Worli end of the Sea Link. As this marvel over the seas was readying, overcoming several challenges, the city added another laurel on the list of its growing infrastructure while enhancing India's stature in the sphere of civil engineering.
We were pioneers in big infrastructure which was based on user fee. Creating, in fact, raising finance from market, constructing huge infrastructure. We were the pioneers in India. In fact, the first state road development corporation was created in Maharashtra. And after this, such road development corporations were constituted or set up in other states. Now, look at it, India is poised at an infrastructure revolution. The first definitive statement came in the concept of golden quadrilateral in 2001, 2004, when we spoke about four-laning of 5,700 kilometers of golden quadrilateral, that is Delhi, Mumbai, Chennai, Kolkata and Delhi. Now, if you look at the explosion, after Mumbai-Pune Expressway or after this, we have recently inaugurated a 9-kilometer bridge on Brahmaputra. Everywhere infrastructure is the buzzword, and it is going to create great opportunities. India is actually now put into in international circuit.
Great cities and great countries are not just a function of their economic might and their cultural heritage, but a showcase for what they can build and what they can have their citizens really aspire to. So in many ways, the bridge has, in some ways, in many ways has actually improved the quality of life of the average Mumbaiker, but it is so aesthetically and pleasing to look at. At the same time, it inspires us as Indians to continue to do bigger and greater things. So besides taking the well wishes and the blessings of so many citizens in Bombay, the number of compliments that we have received from well-wishers and partners and stakeholders and JV partners from around the world for having accomplished this has truly been tremendous. And I think that we are so proud to have actually accomplished this achievement and to have provided something so wonderful to the city of Mumbai and to India.
Another challenge before the makers of Sea Link was corrosion due to its proximity to the sea. This was taken care of with a barrier coating by galvanization. The project also featured the state-of-art surveillance technology and apparatus for maintaining driving discipline. And after 10 years of hard labor, toil and dedication of over 3,000 workers and nearly 150 engineers, Sea Link was opened for Mumbai. Easing life of several thousand commuters and dying a cost for future civil infrastructure.
See, as on today, more than 50,000 vehicles actually use this bridge every day. Both the sides together. And it has eased life so much. In fact, the commute between Mahim and Worli, even though the normal road has become a little more tolerable just because of this bridge. Had this bridge not been there, in last 10 years, you would have found it chaotic to cross Mahim and Prabhadevi and then going to Worli or South Mumbai from this side.
In fact, what it has done is it's changed the social and cultural life of the city. Like, I go to Bandra a lot more often than what I used to because the distance is much quicker. I go to Juhu more often than I used to because it's much more quicker. Besides that, I think it's made connectivity easy. You know, I mean, previously, if you had to take a long distance, then trains were ideally what people would look at. But because, you know, road time was like really painful. But now with the Sea Link, I think it's just kind of made life a lot easier.
I have stayed in all parts of suburban Mumbai. I stayed in Navi Mumbai, I stayed in Thane, I stayed in Goregaon, and then I stayed at Nariman Point. Now I stayed Bandra. Now, all this commute, I was not part of MSRDC in 2010 when this bridge was inaugurated. But at those days, I was serving at Andheri. Going from South Mumbai, for going Worli to Andheri, what was the effort and how easy it became the moment this bridge was inaugurated, I am witness to it. So, it was for any Mumbaiker, this bridge was, I suppose, a statement of Mumbai having arrived on an infrastructure scene. So, I was part of such feeling.
Today, the Bandra-Worli Sea Link, or the officially known Rajiv Gandhi Sea Link, is a prominent landmark of Mumbai. A popular destination for the city residents as well as tourists and even filmmakers. The talk of Mumbai is not just Marine Drive or its famous skyline. The bridge of dreams over her seas has firmly stamped its identity.
Yes, there is a lot of excitement. College students come, engineering students come. People want to go. In fact, even people want to go up the pylon and see, because you know, in pylon, you can rise the entire height of the pylon through a lift. It's very difficult. We don't allow people, but people have that excitement. Even they want to film. This is become, you know, this is the see earlier Mumbai. What was Mumbai's leitmotif? One was Gateway of India. Second was the Marine Drive. Now, the moment Mumbai picture comes, it is the Sea Link, which actually comes as the motive for Mumbai.
I think it's fabulous. I think if we can build a Bandra-Worli Sea Link, I'm sure we can build many other sea links and many other bridges and many other flyovers. You know, we also have the Eastern Expressway that connects from you know, VT CST station right up to you know, kind of Ghatkopar and the eastern suburbs. So I think if we really want to do it, we definitely can. It's just about applying the right time and the right resources to the right causes.
I think that in the minds and the hearts of the average citizen of a city, there has to be a pride in the city one lives in. And I think that in many ways, on one hand, while BWSL has certainly touched the average lives of a Mumbaiker in terms of improving their quality of life, it is such a beautiful and aesthetic site that it provides at least the inspiration to do bigger and greater things, which I think that when you actually look at it from a grander perspective, it signals in some way an aspiration to do bigger and better as we move along.